Hello students, let us understand the concept of polymorphism. In that last video, we had understood what method overriding was and how it was related with polymorphism. So today we shall actually completely understand what do we do in order to achieve a runtime polymorphism. By method overriding, we had seen that a method which is present in base class is also present in the derived class, and how that derived class function gets executed once we call it with reference to the derived class object. And we had seen, in case a function is present in the derived class with the same signature, it overrides the definition in the base class. So how this polymorphism, runtime polymorphism, basically how it works. Now suppose we are having a base class object and we create a reference to the base class, and if there is a derived class whose reference is with us with the name as OB2, we say that a base class reference can refer to all derived class objects. So this is a rule we must always remember. So rule for runtime polymorphism: a reference to base class can refer to all the objects of its derived classes. Now, as we had seen in our own program, that there is one class that is present as base class, and we have its derived class, that is 2, and we are having a method void display which is present in the base class as well as in the derived class with different definitions, right? The base class is having two data members, integer x and y, and derived class is having its own third variable z. So as this 2 is derived from 1, its derived class, its object rather, will contain 3 integer variables, 2 inherited from one class and 1 of its own. So that means in case we draw the diagrams of the two objects, so one object is having an access to one x and y, and this 2 is now, after derivation, it is having x, y and z. So this definitely an object that is bigger of the size of its base class object. Now that we'll see how reference to this one class can actually get the values from two objects, as we had seen in the runtime polymorphism. Now in order to experiment this, let us create one more object. Let us create rather derive a new class, that is 3, and let us extend it from 1 again. So we will be having rather 2 derived classes and 1 base class. And let us have this definition of display here too, void display, and let us actually save this line here too. This is a derived class 3, and this is a definition in 2. So now that, let us move on to any main method. Suppose I'm writing in this main of 2, we can write it in 3 as well as in 1, 2, that does not matter. So let us create a reference to the base class. So now that you can observe, I have not made use of new here because I need not create an object of one class. I just have a reference to. And now let us create an object of new class, new OB1, that is rather is a reference to Let us create an object of 3 class, that is ob2 is equal to new 3. Now the rule said that I can assign any reference of derived class to the base class. So this is also true. So in case this is true, what if I make a call to this display method with reference to ob? Now after that, let us assign this reference to the second derived object, that is ob2, and then call this display method. As you can see in this experiment, I have made a call to this display function twice. The statements are similar, but once I called this display function, before that I had actually assigned the object of 2, that is a derived class of 1, to this ob, and after that I changed the reference to ob2. Now ob2 is a reference to 3 class, and once I am calling this display method here, so now these two calls will actually lead to two different results. Rather, by look of it, it should feel like they will be displaying the similar output, but here it will not. It will actually intend to make different calls. So these are actually different calls. This is what was essence of polymorphism, that you are having multiple forms of similar methods, and through these multiple forms you are able to call them using different calls. And method is one. There is one method that is having display, and it is having two forms present in two derived classes, and through them we will be actually observing that these two classes will be giving you two different outputs. In fact, I can also refer to the display call that is present in the base class also. So let us first run this and observe the output. Compile the program and let us run this too. Let us first save this program. It was unsaved. Let us run this. This class is having the first letter as capital, that's why it was showing you this error. Let us compile it again and let us run this. As you can see that you are actually calling this display function and giving the results are different. The first call was of 2, the second call of display was related with 3. So this actually completes the definition of this polymorphism and shows you that one particular function present in two different classes and two different derived classes, and call made with reference to the base class reference only. How can it lead to two different calls? So this is all about polymorphism. Let's meet in the next video where we shall understand the concept of abstract classes and interfaces. Thank you for this time. Bye bye.